CC from third sem SVC, College of Engineering. Here I'm doing a presentation of math where Latin square design and analysis is the topic of this is an experimental design is crucial aspect of a specific research, allowing researchers to systematically investigate the relationship between variables and draw reliable conclusions. One such powerful experiment design is the Latin square, which offers a unique approach to controlling of for multiple sources of variation in these presentation. We we will dive into the Latin square designs, their advantages and limitations, and applications for analysis of covariance to further enhance the insights guaranteed from these experiments. Introduction to experimental design. Principle of experimental design. Experimental design is the foundation of significance research guided in the systematic investigation of research questions. Key principles include randomization, replication, and local control, which helps minimize the impact of co-founding variables and ensure the validity of results. Importance of experimental design. Proper experimental design is essential for drawing reliable conclusions as it allows researchers to isolate the effect of variables of interest and control for potential sources of bias. This in turn enhances the internal and external validity of study findings. Types of experimental design. Researchers have a wide range of experimental design at their disposal, such as completely randomized designs, randomized block designs, and Latin square designs, each with in its own strength and applications. Principle of randomized designs. Randomized assigning treatments to experimental units is a core principle of experimental design as it helps ensures the unbiased distribution of co-founding factors and allows for the valid use of statistical interface. Replication. Repeating the experiment multiple times or replicating provides a better estimate of the truth treatment effect and increase the statistical power of the analysis. Local control, accounting for known source of variation such as blocking or using a Latin square design can help reduce the error variations and increase the precision of experiment results. Defining Latin square designs. What is a Latin square? A Latin square specialized experimental design that controls for two sources of variation, typically rows and columns. In addition to treatment effects, this design is commonly used when there are three or more treatments to be compared. Assumptions of Latin squares. For a Latin square design to be valid, it is assumed that the row and column effects are additive and independent of the treatment effects, and that there are no interaction between the blocking factors and treatments. A Latin square is constructed by arranging the treatment in a square grid such that each treatment appears exactly once in each row and each column. This ensures that the effect of two blocking factors are accounted for in analysis. Advantages of limitations of Latin square. Advantages. Efficient use of experimental units by controlling for two sources of variation, increased statistical power and precision of treatment effect estimates, liability to investigate the effect of two blocking factors simultaneously, limitations. Restricted to a maximum of n treatments where n is the number of rows and columns, assumptions of additive and independent rows and columns effect must be met, limited flexibility in experimental design as layout is permanent. Construction Constructing a Latin square design, determine the number of treatments. The number of treatment must be equal to the number of rows and columns in the Latin square. Assign treatments to the cell. Each treatment must appear exactly once in each row, and column must follow a specific pattern to ensure the design is balanced. Randomize the treatment. Once in a Latin square is constructed, the order of the treatment within each row and column should be randomly assigned to ensure the design is unbiased. Analysis of variations in Latin square. A ANOVA model of Latin square. ANOVA model of Latin square design includes terms for overall means, row effect, columns effect, and treatment effect, with the residential error representing unexplained variations. Patronizing the source of variations, the ANOVA table of Latin square design uh, personates the total variation into variation attrib- attributes to row columns treatments and the residual error, allowing for estimation of treatment effects while controlling the uh, Nursican factors. The F test performed at the hypothesis testing. The F tests performed on the ANOVA table are used to determine the statistical significance of the treatment effect as well as the row and column effect, providing instance into the revealing importance of each other. Assumptions of ANOVA for Latin square. Normality, the residual from the ANOVA model should follow a normal distribution, which can be assessed through normality test or visual inspection of residual plots. Independence, the experiment observation should be independent of another, as validity of statistical interface relying on this assumption. Homogeneity of variance. This variance of residuals should be content across all the treatment groups, which can be evaluated through lattice test or visual inspection of residual force. The row and column effect should be additive and independent of the treatment effects, a key assumption of Latin square design. What is an ANCOVA? Analysis of covariance is extension of ANCOVA technique that allows researchers to incorporate one or more covalents of a variable that may influence the outcome of interest into the analysis. ANCOVA for Latin squares. When applied to square design, ANCOVA can further enhance the insights gained by controlling of for additional source of variations beyond the rows and column effect, leading to a more comprehensive understanding of experimental systems. Benefits of ANCOVA. ANCOVA can increase the precision of treatment effects, estimates by accounting for variability explained by Covarence, potentially increase the statistical power of the analysis and providing more accurate assembly of the treatment. Conclusion and takeaways. Latin square design offers a powerful approach to experiment research, allows researchers to control for two sources of variation while investigating the treatment. Analysis of variance and ANACOVA framework provides a robust method of analysis. The results of Latin square experiments postulating the source of variations and testing the significance of treatment effects, analysis of covariance, incorporating ANCOVA into analysis of Latin square design can further enhance the insights gained by accounting for the additional source of variation, leading to more precise and reliable conclusions. In summary, the combination of Latin square experimental design and the advanced statistical technique of ANCOVA provides researchers with a comprehensive toolkit for conducting rigorous and informative studies in a wide range of scientific disciplines. My name is Sri. My USN is 1B23CS157. I'm studying in Sri Venkateswara College of Engineering. Please subscribe, share, like my videos. That's all for today. Thank you. Bye bye.